This is Team 14, consisting of Bhumika, Derek, and Indusha. We have created a decision support system through which users will be able to streamline their house hunting process, quickly determine what location will help them earn the highest profit for renting an apartment or location on Airbnb. And on the right here is just a preview of the front-end design of our decision support system. So the business problem that we're trying to solve is basically purchasing an apartment to rent out on Airbnb can be very profitable if done correctly, but it requires a large investment and proper selection of location. There are many external factors that influence the potential profits of renting out a particular apartment on Airbnb, such as location or room accommodations, surroundings, etc. And because of these factors, it can be difficult to decide on an optimal apartment to purchase, and the renter may not see the return on investment that they were hoping for. So our DSS is basically going to solve this business problem. Our system will ease the process of choosing an apartment or location to lease in order to rent out on Airbnb, given multiple factors such as location, room layout, price to lease, price to rent, etc. And our system is made for general users who are just looking to generate some income through renting out places on Airbnb. So therefore, by implementing and leveraging machine learning concepts, our decision support system will be able to predict the profits that a user can expect on a particular apartment and basically highlight the optimal apartment to purchase, and as a result, save time and money for the user.
First of all, the user just needs to have two addresses of two possible locations that they want to choose between buying. So using this location data that the user is going to provide, our system will leverage a random forest regressor to predict an Airbnb rent price for both of the locations. After predicting this rent price, the system will calculate the highest possible profit the user can earn from renting at the specified locations. Based on these two profit values, the system will display address, longitudinal and latitudinal coordinates, market price, and estimated rent price and profit for both of the locations, and will highlight the most optimal location to lease and rent out on Airbnb. Just to give a little bit more insight into how the machine learning was done for the purposes of this project, we used a random forest regressor as our machine learning model of choice. And this model has been trained on a few different key features, namely latitude, longitude, room type, as well as minimum number of nights. In order to make predictions, the machine learning model takes input data corresponding to these four features in order to make a prediction on the Airbnb price that an apartment can be rented out for.
So when building our system, we made a few assumptions. The first being that the rent price doesn't change over time, and the user will only want to compare two locations at a time using our system. And all the calculations will be made on a yearly basis, so lease, profit, and the apartment of choice will be booked out for the entire year on Airbnb. And we're also assuming that the apartment will be paid off with the same monthly price for 40 years. And the entire apartment itself will be rented as well. And a minimum of one night stay will be required per Airbnb booking.
So in order to actually train the machine learning model, we used a data set from Kaggle, which is an open data set describing New York City's Airbnb data. And this was pretty much the data that we used to train our machine learning model. The model will consume these four different parameters, reshape them in a way that can be inputted into the model, and then make a prediction with that. So before it can get these four parameters, however, it needs to make an API call. And we also handle that in the backend using Flask and Python. The thing that ties this all together is, of course, the user interface on the front end, where the user provides an address for two of the locations that they want to be comparing. And then this information is then sent to the backend, which is then converted into latitude and longitude via the API call. And then the entire machine learning prediction process kicks off. So here we have in the folder mlmodels.py, we have the necessary imports that we're going to be using in order to create the model, as well as manipulate data, etc. So the functionality of the machine learning model is wrapped up into three main functions, which are going to be called later on by various API routes. So the first and probably most important one of these is the train function. And what this function does is it essentially trains the model, the random forest regressor that we're using, in order to make predictions. Now, this is done by first setting a prediction target, which is essentially what you want the machine learning model to spit out an answer for, and then describing the various inputs that the machine learning model will have to examine in order to make a prediction. One of these input types is actually non-numeric, which is the room type. This is known as a categorical feature, which just means that we will have to do additional data manipulation before training the model so that the model can actually interpret the information that it's being fed. And this data manipulation is done here, and it's known as one-hot encoding. And now that we have our input data, which is specified in the X variable set, we're ready to split our data into training and validation sets. And this is done just so that the model can be evaluated correctly and not on the data that it was trained on. This allows us to get a real estimate on how well the model is doing and not overestimate the capabilities of the model. So here we set the parameters for training, and then we fit the model, aka train the model, in this line. And then at this point, we are ready to persist the model and use it in the rest of the application to make predictions. This next function is what allows the system to actually predict using the model. So if the model has already been trained and is loaded, it will take the input parameters specified here and then do the necessary manipulation to get them into a format where the model can actually understand the inputs. And this is done in these lines. After this point, we're ready to send the data into the model and receive a prediction. The prediction will be given as a single floating point number. And so we store the result of the prediction in this variable prediction. Finally, we return the predicted value. And if there's no model yet, then we'll prompt the user of the system to train the model first. Finally, we have the load model function. And this is mainly a sort of utility function that's called automatically when the server is started up, so that it'll load the machine learning model that was already trained before any methods such as predict price are called. These ML models are actually only accessible through the API. And so the various routes that we've made available through the system are available here. And the only thing that will be interacting with these API routes will be the front end. This is how the front end is able to call functions in the back end. The primary function that the front end will be calling is the get data function through this specified API endpoint. What this function does is it searches for the addresses that were inputted in the front end that the user wants to compare. These addresses are then fed into an API request to an external data source where the latitudinal and longitudinal data can be found associated with these addresses. Once we have this data, we are ready to actually make a prediction using the model. And so we set a few variables to be able to reference the data that we need, which is the latitude, longitude, as well as the market value of the actual property. Once this is done, we just do another check to make sure that our machine learning model is properly loaded. And at this point, we're ready to make our prediction, which we do here, which calls the methods that we just walked through. We save this value here, and then we call another set of functions housed in the monthly stats file to actually generate the stats that we need. We'll quickly walk through how profits are calculated. So in profits.py, we have a few functions that do some simple math to just calculate and put the numbers in a usable format for the rest of the application. So here we can see that we're calculating the monthly payments that the user will have to make in order to afford buying this place, the yearly revenue that this user can expect by renting it out on Airbnb, as well as monthly revenue, monthly profit, and yearly profit.
So in order to build a front end, we used React.js. React mostly consists of components. The app itself is actually rendered in app.js, which I have open right now. And we use one main component called search. So the search component, I'll just walk through it quickly. So each component has a state, and the state is what we use to display values and hold values on our front end. So the first set of values that we actually take when the component is rendered, we have a form that allows the user to find the optimal location that they're looking for. So this form actually takes the city and the state for two different addresses as well as the address. And then once the user inputs these field values, our component actually holds that information within the form fields. So address 1, city 1, address 2, city 2. So these would be fields that the user enters, for example, if they want to compare two different apartments that they're looking at. And then after they fill out the form, upon submission, we have a function called onSubmit. And the onSubmit function essentially calls the API endpoint that we made, inputting the fields that the user inputted. So for form field 1 address and form field the city state 1. So these fields are actually then used to fetch the data and also perform the backend APIs that we need. Now the listing data consists of the data that we got using our fetch statements. So in order to display that data, we use a listing component. And this listing component is given the state information that we declared. So the information for property 1 and the information for property 2 is sent to the listing component, as well as the listing component information for the other one in order to compare which property is a better selection. So the listing component itself is fairly simple. It's just used to display information that we want to show the user. So it shows the address that we were able to get, as well as the market price and various other information about the property itself, including a short summary and the location. And it also shows the information that we got using our machine learning models and our backend. After we display that data, we also have to show the user which property is optimal. So in order to do this, we just simply show which property that they should choose in green. So we have a style essentially, and we have other styles as well to do that. And it essentially checks which properties monthly revenue is greater and displays that property as green.
I am a user of this system, and I want to decide between two different apartments that I've had my eye on for a little bit. I think that they're both worthwhile investments, but I'm just not really sure which one is going to be the better one overall in the long run. And it's quite a lot of money to purchase an apartment. So I think the first apartment I want to go with, and I'm looking to buy both of these, looking in New York. The first of these listings at 336 East 77th Street. The next listing that I want to look at is, let's say I want to look at 159 West 136th Street, also New York. So from this, I want the system to plainly tell me which apartment is going to make me more money, because that is what I care about as a user of the system. Now that I've clicked submit, I'm waiting for the system to pull up the necessary data, and here we go. So first things first, we see that I'm offered two separate tables, and both of these contain additional information that I didn't actually have to input. So all I had to do was input these addresses, and what I'm left with is the full address, zip code, the market price currently of this listing. We have the coordinates and longitude and latitude of both of the listings, as well as just a brief summary of what both of these places actually are. So all of this data was actually gained from the backend, which performed an API request to an external service that provides data on house listings. Given that's the case, I know that the system is telling me I'll have to pay $2,010 for 336 East 77th Street and $1,510 for 159 West 136th Street. Furthermore, I know that the monthly profit that I'll be gaining by purchasing and then renting out this listing is going to be $5,052. And how do I know this? Well, because in the back end, the machine learning model is leveraged to predict a price that I can offer my listing for on Airbnb um, every single night on a per night basis. With this data, I can clearly see that on the left-hand side, which is already highlighted green, I'll be making $5,052 compared to the right-hand side, where I'll be making $3,033. Now, this is a very important point about our system because it provides users not just with a selection that makes money, but also helps them choose the apartment that'll make them more money and actually give an estimate as to how much exactly they can expect to be making more.
In terms of operational improvements, users will be able to streamline their house hunting process. They'll be able to easily decide between two different properties that they're looking at and be able to see which one maximizes the money that they spent. Thank you for listening to our presentation. We've learned a lot about making real-world decision support systems.